Welcome back, Geometry Scholars. Today is lesson 9.5 on properties and conditions for kites and trapezoids. Our essential question continues to be, how can you determine the similarities and differences between various quadrilaterals? And the objective is that you will be able to define and identify by their properties and special conditions kites, trapezoids, and isosceles trapezoids, and then explain how they are related to the larger group quadrilaterals. As always, if you have questions, write them in the margins. And let's get started. Kites and trapezoids are quadrilaterals that are not parallelograms. So quadrilaterals have four sides, but they are not parallelograms. Let's talk first about a kite. A kite is a quadrilateral with two distinct pairs of congruent consecutive sides. So congruent, obviously they're equal. Consecutive means they're touching each other, or they're next to each other. They have no parallel sides because they're not a parallelogram. The diagonals are perpendicular, which you can see that right here. The diagonals, when they intersect, make right angles. One diagonal bisects the other. So one diagonal is cutting the other one in half. So BD would be cutting CA in half. The fourth bullet says one of the diagonals bisects the pair of non-congruent angles. So that means that it bisects that angle and it bisects that angle. Okay, and I had to draw that far out so you could see it. Two pairs of consecutive sides are congruent. BC congruent to AB. I'm sorry, BC congruent to BA, and DA congruent to DC. And one pair of opposite angles are congruent. I'm sorry about that. So you can see the opposite angles are congruent. Okay. If you have a hard time figuring out which angles it is that are congruent, think about this piece right here. Okay, that diagonal. It has cut the kite into two congruent triangles. Okay, I know it's congruent because side and side, and then it shares a side. So they're congruent by side, side, side. That means any of their pieces are congruent to the other pieces. Okay, any of their pieces are congruent to the other pieces. So angle C is the angle that would be congruent to angle A. Okay, that's how I remember which angles it is that are congruent. So kites, a lot of tricky things about kites, but really think about it as two triangles and it's much easier. A trapezoid is a quadrilateral that has one pair of parallel sides. The sides that are parallel are called the bases, and the other two sides are called the legs. That's the basic thing about a trapezoid. But then we have isosceles trapezoids. Isosceles trapezoids have one pair of parallel sides, just like a regular trapezoid. But then they're called an isosceles trapezoid because they have two congruent sides, or two congruent legs. Third bullet point, each pair of base angles are congruent. So A is congruent to C, or B is congruent to, A is congruent to D, B is congruent to C. And the diagonals are congruent to each other. So all the diagonals are congruent to each other. Okay. Sorry guys, I apologize for the announcement that came on again. So let's go on to example 1 and 2. So example 1, letter A, find the measure of angle 1. So again, what you're dealing with right here, okay, crazy day with announcements. So what you're looking at right here are two parallel lines, and they are being intersected by these transversals. So we're resulting in consecutive angles or same side interior angles. So 1 and this angle up there, they have to add up to 180. They're supplementary. So 1 and this angle have to add up to 180. Well, if that one's 90, how much is 1 going to be? Because angle 1 plus 90 equals 180. So angle 1 is also 90. The same thing is true over here. Angle 2 and angle 53 have to add up to 180. So angle 2 plus angle 53, I should say angle 53, angle 2 plus 53 equals 180. So when I subtract, angle 2 is 127. And did I add correctly? Yes, angle 2 is 127. So it just turned out, we just kind of got lucky that angle 1 is congruent to this angle up here. What has to happen is they have to add up to 180. But since the top one was 90, this one down here has to be 90 as well. Okay? Let's go on to example B. In example B, we have to find 1 and we have to find 2. So first of all, looking at these, I can break it down into 2 congruent triangles. So angle 1 is congruent to the opposite angle. So angle 1 is 110. Okay, they're congruent to each other. Now, this diagonal has bisected the angle, okay, because it's the diagonal that's bisecting the non-congruent angles. Angle 1 and 110 are the congruent angles, so the diagonal that goes across. So that means it's cutting this angle in half. Well, how much is that angle worth? That angle is 90. So what's half of 90? 45. So this angle right in here is 45. So I have 110 and I have 45, which is 155. If I subtract 180 minus 155, that's going to give me angle 2, the third angle. So angle 2 is 25 degrees. A lot of this right here is either, remember, it's congruent to each other or they're adding up to 180. Example 2, find the value of x. Okay, looking at this picture, I see that I have my kite, and here are my congruent sides. So this side is congruent to this side is congruent to that side, and then I have the third piece. So my opposite angles are congruent. So x minus 6 equals 25. X minus 6 equals 25. I add 6 to both sides. X equals 31 degrees. Now, there was also a longer way you could have done this. If you didn't catch that x minus 6 was equal to 25, you could have, I'm going to write the word or and box it in. You could have said, well, I know that 2x plus x minus 6 plus 3x equal 180. All those angles equal 180. So you could have, and then you could have solved for x that way. You still would have gotten x equals 31. So either way of solving it is fine, but hopefully you recognize that x minus 6 is equal to 25. Let's go on to example 3. Find the perimeter of the kite. Use the Pythagorean theorem to find the side lengths of the kite. So I can see here that I have 3 and I have 7. So I'm looking for WE. So 3 squared plus 7 squared equals C squared. A squared plus B squared equals C squared. So 9 plus 49 equals C squared. 58 equals C squared. The square root of 58, so the square root of 58 is C. So this is the square root of 58. And I can't factor that out anymore. If you use a calculator, you can figure out what it is. It's going to be somewhere between 7 and 8. Okay? So that's the square root of 58. But ES is also the square root of 58 because it also has a 7 and a 3. So now we're going to find the length of WT, and it's going to be the same length as ST because it's a kite, so it has 2 sets of congruent sides. So 3 squared plus 10 squared equals C squared. 9 plus 100 equals C squared. 109 equals C squared. And we need to square root of 109 equals the square root of C squared. So this is the square root of 109, the square root of 109. So now we have to add all of that up together to find the perimeter. So I have square root of 58 plus square root of 58, which I have 2 of those, so I now have 2 square root of 58 plus the square root of 109 plus the square root of 109, so 2 of the square roots of 109. And this is my perimeter. Now, if you used a calculator and found what the square root of 58 was, that's perfectly fine. But you did not have to go that far. You could have left it as a square root. Find the values of x and y. Now, this is an isosceles trapezoid, and I can tell that because it has a pair of congruent sides. So don't forget, their base angles are congruent. So that means that this angle is congruent to that angle. So angle 1 is also 74 degrees. And then angle 1 and angle 2 have to add up to how much? They have to add up to 180. So 180 minus 74 equals angle 2. I'm not sure what's going on here right now. So 180 equals 106 equals angle 2. I'm not sure why the board's messing up. So angle 2 is 106 degrees. So they were either congruent or they were supplementary. Let's look on example B. We need to find x. I have 3 things that x equals. However, I notice that this side is congruent to that side. So I can set up those measurements as congruent to each other. X plus 5 is equal to 3x minus 3. And now all you're doing is solving for x. Go ahead and please pause the video and solve for x. Okay, you solve the equation and you get x equals 4. And please go ahead and write the code word dentist in your summary. Code word dentist in your summary. And it's dentist because I'm going to the dentist today. Moving on to the trapezoid midsegment theorem. The midsegment of a trapezoid is the segment whose endpoints are the midpoints of its legs. It is parallel to each base, and its length is 1/2 of the sum of the lengths of the bases. And so this is kind of like the triangle midsegment, but finding the length is a little trickier. It's not just half, it's half of the sum of them. So let's see this in action. Example 5. Find the length of each midsegment. So I'm looking for MN, and I know MN is the midpoint because it cut PS in half and it cut QR in half. So to find the length of it, you add up 9 plus 16, so 1/2 of 9 plus 16. So 1/2 of 25, so you could write 25 over 2 or 12.5. Either way will work. Okay? There have literally been like 5 announcements today. Okay, the next one's a little bit trickier. The midsegment I have, okay, I know that it's y plus 6 is equal to 1/2 of 3y minus 7 plus y plus 3. Okay, so we had to add up these 2 pieces and then cut them in half. That's what y plus 6 is. So I don't want to be dealing with a fraction, so I'm going to multiply both sides by 2. By doing that, I now have 2y plus 12, and I was able to cancel out that fraction. So 2y plus 12 equals 3y minus 7 plus y plus 3. Okay, by multiplying everything by 2, I now have 2y plus 12 on the left, and that on the left on the right canceled out. So 2y plus 12 equals 3y plus y is 4y. Negative 7 plus 3 is negative 4. Moving to subtract 2y from both sides. 12 equals 2y minus 4. We're going to add 4 to both sides. 16 equals 2y. So y equals 8. Okay? Y equals 8. Okay, you have a summary. Please make sure that you write at least one sentence about what you've learned, and I will see you next class.